Hi all. This is another question for shaft. Please listen the question. A steel solid shaft transmitting 15 kilowatt at 200 rpm is supported on two bearings 750 mm apart and has two gears keyed to it. The pinion having 30 teeth of 5 mm module is located 100 mm to the left of the right hand bearing and deliver power horizontally to the right. The gear having 100 teeth of 5 mm module is located 150 mm to the right of the left hand bearing and receives power in a vertical direction from below. Using an allowable stress of 54 megapascal in shear, determine the diameter of shaft. So, in this question they are given in between two bearings, one shaft is located. On that shaft, two gears are attached. So, first of all, we can draw the space diagram. The space diagram will be like this. We have two bearing A and B and we have two gear. First gear we can name it as C and that C is 150 mm from the bearing A and another gear D. This gear is 100 mm to the left of the right hand bearing. So, these conditions are given in the question itself. And here the smaller gear is marked as pinion and the bigger is marked as gear. The smaller, that is the D gear, is rotated in the horizontal direction only. That is also specified in the question itself. And the bigger, that is the gear, is transfer the power in the vertical direction. That is shown here. So, this is the space diagram that we have to draw first. Now we can do the question. We can write the given data, that is given P is equal to 15 kilowatt or convert it into watt and the speed is given, that is equal to 200 rpm. Once more. The power P is equal to 15 kilowatt and the speed N is equal to 200 rpm. The distance between the bearing, that is AB, is equal to 750 mm. TD, the number of teeth on D is given, that is equal to 30 and the module is given, that is equal to 5. Then BD, the distance between bearing and the gear is 100 mm. Now the number of teeth on C, gear C, that is denoted as TC, is equal to 100. Module of that particular gear is 5. Then AC, that is the distance between the bearing and the gear C, is given, that is equal to 150 mm. Now tau is also given, that is for the final calculation. Now we can draw the space diagram. We already drawn that space diagram. Now we can find the value of torque using this equation, P into 60 divided by 2 pi N. It is a general equation. The power is given and also the speed is given. If we substitute all these values in this equation, we will get the value of T. Now, it is the general condition, that is the diameter of the gear is equal to number of teeth into module. It is a general equation for a gear, already studied in the MOM, mechanism machines. Here the radius of the gear we can calculate it, RC is equal to TC into MC divided by 2. That T is the number of teeth and M is the module. Here for gear C it is 100 into 5, that is equal to 500 divided by 2. So we will get the radius of the gear C. Now we can find the radius of the gear D. The teeth is given, that is equal to 30. Again module is given, that is equal to 5. If we calculate, then RD is equal to 75. So we find the values of RC and RD. Now we can go for the tangential force. Tangential force we already calculated in the previous problem. Ft is equal to T by RC. T we already calculated and RC value of RC is for the radius of the gear C. If we substitute this value, we will get FTC, that is the tangential force, is equal to 2870 Newton. Now it is for the same for the pinion. How we can calculate? Using the value of RD. T is same because we assume the torque on the shaft are same. So FTD is equal to 9550 Newton. Now we can draw the vertical and horizontal load diagram using this condition. So at point C it is 2870 and at point T it is 9550. Here in this vertical load diagram there is no D, because in the question itself they are given that the horizontal load act only at points, the vertical load acting only at C, and there is no vertical load on D. So here in the vertical load diagram there is no D. Similarly, in the horizontal load diagram we have only D, because as the question itself they have shown that D have a horizontal load, there is no vertical load in D. There is no vertical load in D and there is no horizontal load in C. That means here the horizontal load diagram there is no value at point C. Thus we calculated or we draw the vertical and horizontal diagram. Now we can go for the moment. How we can find the moment? First of all, we have to find the value of reaction load at A and B in vertical load diagram. We know that RAV plus RBV is equal to 2870, and if we substitute the value, this value is obtained from this equation, that is RAV here and RBV is here, that is on the topward direction or upward direction, and RC, that is the load at C, is in the downward direction. So RAV plus RBV is equal to 2870 Newton. Now we can take the moment at point A. Taking moment at point A, we can take RBV into 750 is equal to 2870 into 150. So if we substitute this value, then we will get RBV. Once we get RBV, then we can find the value of RAV also. That is RBV is equal to 2870 into 150 divided by 750, that is equal to 574. If we substitute the value on the previous equation, then we will get the value of RAV, that is equal to 2296. Now taking the moment about A and B. Is there any moment at A and B? No. In the vertical direction there is no moment at point A and B. Now we can go for the moment at point C. What is the value? MC is equal to RAV into 150. RAV into 150, that is equal to 2296 into 150. We will get that value. Similarly, we can find the bending moment at point D in the vertical direction. What is that value? RBV into perpendicular distance, that is equal to RBV into 100. So we will get two values, point C and D. We can draw this vertical bending moment diagram like this. Okay. Now we can go for the horizontal bending moment diagram. How we calculate? On the same manner of the vertical direction. RAH plus RBH is equal to 9550. Now taking moment about A, RBH into 750 is equal to, using this equation we will get the value of RBH. Once we get the RBH, now we can find the value of RAH. So RBH and RAH we already calculated. If we got these two values, we can go for the moment, bending moment. At point A and B, there is no bending moment because there is bearing. Next, at point C, we can calculate using this equation, that is RAH, the H for horizontal, RAH into 150, that is perpendicular distance. Then we will get the bending moment at the point C. Then at point D, we can calculate using RBH into perpendicular distance. Then we will get the bending moment at D also. Now we can complete that figure. The horizontal bending moment will be like this. These values are scaled value. So draw this figure in your note also. After finding the values of RAH, MDH and MDV, also MCH and MCV, we can calculate the bending moment at each point, that is the total bending moment or resultant bending moment. How we can calculate? MC is equal to root of MCV square plus MCH square. MCV we already calculated and MCH also we calculated. CV for vertical and H for horizontal. If we take these two values, we will get it is bending moment at point C, that is equal to 393 into 93.79 into 10 raised to 3 Newton millimeter. Similarly, we can find the value of bending moment at G. So compare these two values. Which value is greater? The greater value is for at point D, that is 829.69 into 10 raised to 3 Newton millimeter. So using that value, we can find the diameter. Thus, we can find the diameter using this equation. The equivalent testing moment, we know that T is equal to root of M square plus T square. M is for the maximum value, that is for the greater value here at point D, that is 829.69 into 10 raised to 3. Then what is the value of T? That we already calculated, 716 into 10 raised to 3. So if we substitute these values, we will get the equivalent twisting moment. Once we get the equivalent twisting moment, now we can go for the calculation of general equation, that is T is equal to pi by 16 tau D cube. Here the tau value is given, that is equal to 54, and D is the only unknown parameter. If we substitute the equivalent twisting moment and tau in this equation, we will get the value of diameter, that is equal to 47, and we have to approximate it into 50. Okay, that is the diameter of the shaft. Thank you.